Let D be the region in XYZ space defined by 1 is less than or equal to x is less than or equal to 2, 0 is less than or equal to xy is less than or equal to 2, and 0 is less than or equal to z is less than or equal to 1. Evaluate the triple integral over the region D with respect to z, then y, then x, of the function x squared y plus 3xyz by using the transformation u equals x, v equals xy, and w equals 3z. Let's first write our transformations. This will be t of u comma v comma w, and that will be equal to u, or parentheses u, comma v over u, comma 1/3 w, close parentheses. And that is us rearranging those values that we were given. X equals u, y equals v over x, which would be v over u, and z equals w over 3 because w equals 3z. That's us rearranging that. Now we can write our Jacobian matrix. J of u comma v comma w. That will be equal to the determinant of a 3 by 3 matrix. And our first row, have a value of 1 for the first entry. Second entry is negative v over u squared. And our third entry is 0. Our second row, first entry of 0, second entry of 1 divided by u, and a third entry of 0. And our third row, a first entry of 0, a second entry of 0, and a third of 1/3. And when we find the determinant of that matrix, using probably cofactor expansion or something like that, we get 1 over the denominator 3u, end fraction. Now along with this, we want to define what our region is so we can set up our integral. We can define the region D as the set of ordered triples u, comma v, comma w, such that 1 is less than or equal to, actually let me set that up differently. So the ordered pairs u, comma v, comma w, such that 0 is less than or equal to w is less than or equal to 3, 0 is less than or equal to v is less than or equal to 2, and 1 is less than or equal to u is less than or equal to 2. Now that will set up our integral as being the triple integral. First outermost integral is from 0 to 3 with respect to w, of the integral from 0 to 2 with respect to v, of the integral from 0 or from 1 to 2 with respect to u, of the function 1 over 3u, end fraction, open parentheses, uv plus vw, close parentheses. Now take a moment here and convince yourself that x squared y becomes u times v, and that 3xyz becomes vw. Look at the relationships we have, u equals x, v equals xy, w equals 3z, and I hope you can convince yourself of that fairly quickly. All right, we'll take our innermost integral. This will become integral from 0 to 3 with respect to w, of the integral from 0 to 2 with respect to v, of the function 1/3 times v plus 1/3 times vw times natural log of u. Actually, that's going to be a natural log of 2. That function is 1/3 v plus 1/3 natural log of 2 vw. Okay, yeah, that's correct. All right, now that will be equal to the integral from 0 to 3 with respect to w of 2/3 plus 2/3 ln of 2 times w. And evaluating this one final time with respect to w, this becomes 2 plus natural log of 8, or 2 plus 3 natural log of 2.